Welcome students. Now let us revise few data models. So what is data model? A data model is a collection of tools for describing data, data relationships, data semantics and data constraints. Data are some processed information like name, phone number, address, etc. And relationship between these data, that is relationship between student details, personal details and academic details can be considered as their data relationship. Semantics is data type or format of data stored in a particular model or database system. And the data constraints are some rules we are imposing on data. For example, name should not contain any numeric values. Phone number should contain only numeric values. And salary should be always greater than 0. These are the few constraints that we can impose on data. Underlying structure of database is the data model. So a collection of conceptual tools for describing data, data relationships, data semantics, and consistency constraints can be considered as a data model. A data model provides a way to describe the design of database at physical level, logical level, and view level. What are the various data models? Few of the data models are relational model, entity relationship data model, object-based data model, that is object-oriented or object relational data model, semi-structured data models like XML, network model, and hierarchical model. So what is relational model? Relational model uses a collection of tables to represent both data and relationship among those data. Each table in a relational model has multiple columns and each column has a unique name. Tables are also known as relations. The relational model is an example of record-based model where data is stored as records. Record-based models are so named because the database is structured in fixed format, records of several types. Each table contains record of a particular type. For example, consider a student database. A student database may contain multiple tables like student personal details, students' academic details, students' extracurricular details. So, database is student which contain multiple tables like personal details, academic details, and extracurricular details. And when we consider each and every table or each and every relation, for example, personal detail contains multiple fields like student number, student name, their phone number, parents' information, address, etc. Whereas academic details contain informations like the marks they secured in various exams. Extracurricular details contain information like there are some extra capabilities like their capability for dancing, music, etc. So each table contains records of particular type and each record type defines a fixed number of fields or attributes. As told earlier, a student personal detail table may contain student number, student name, their address, parents' details, etc. The columns of the table correspond to the attributes of record type. The relational data model is a most widely used data model and a vast majority of current database systems are based on this relational data model. The main highlights of this relational data model are data is stored in tables called relations, and these relations can be normalized to avoid duplicate values. In normalized relation, values saved are atomic values. Each row in a relation contains a unique value. Each column in the relation contains value from a same domain. These are the main highlights of relational data model. This is an example of a representation of relational data model. This is a table which can be either called as relation. And this table contains multiple columns like SID, SNAME, SH, SClass and SSection. This is a table representing some student details. And these columns like SID, SNAME, SH, SClass can be considered as attributes. And each row in a table is called tuple. And this table as a whole or collection of rows or collection of tuples is called relation or table. This is a simple example showing relational model. And the next is entity relationship model. The entity relationship data models uses a collection of basic objects called entities and relationship among these entities. An entity is nothing but a thing or an object in the real world. For example, considering a college, student can be considered as an entity. Teacher can be considered as an entity. Academic or non-teaching staff can be considered as another entity. So these entities are nothing but they are some real world objects. Entity relationship model an enterprise as collection of entities and relationships. Entity, as I told earlier, is a thing or object in the enterprise that is distinguishable from other objects. For example, in the given example, customer is an entity, account is another entity. And each entity has a set of attributes. The attributes of customer entity are customer ID, customer name, customer street, and customer city. Whereas the attributes of account entity are account number and balance. And there is a relationship between these two entities, and the relationship here is a depositor. Customer is a depositor for an account. We can read this as follow. So relationship is an association among several entities. And in the case of entity relationship model, these entities, their attributes and the relationships can be represented diagrammatically using a diagram known as entity relationship diagram. This is a simple example of a small entity relationship diagram. The entity relationship model is based on notation of real-world entities and relationships among them. ER model is best used to represent conceptual design of a database. ER model, as told earlier, is based on entities and their attributes, relationships among entities. And we can define entity in ER model as a real-world entity having properties called attributes. Every attribute is defined by its set of values called domains. For example, in a school database, a student is considered as an entity. Student has various attributes like name, age, class, etc. In the case of entity relationship model, the logical association among entities is called relationship. Relationships are mapped with entities in various ways. Mapping cardinalities defines number of associations between two entities. Mapping cardinalities can be either one-to-one, one-to-many, many-to-one, or many-to-many. In case of one-to-one, both sides, one entity is associated to one another entity. In case of one-to-many, one entity is associated to many other entities, and so on. This is an example of again an ER model where entities are represented as rectangles, attributes are represented in oval shape, relationships are represented using a diagonal symbol. Next comes a hierarchical model. Hierarchical model organizes data into a tree-like structure. In this model, Each entity has only one parent but can have several children. In the hierarchical model, we are representing a parent-child relationship. At the top of hierarchy, there is only one entity which is called the root. Sibling records are sorted in particular order. That order is used as physical order for storing the database. This model is very good for describing many real-world relationships. Parent-child relationships can be easily represented using hierarchical model. This is an example of hierarchical model where a root node is department. Under department comes its children like course and student. And even the course has a child called professor. So this is a way of representing a hierarchical model. Now comes the next model, network model. The network model builds on hierarchical model by allowing many-to-many relationships between linked records, implying multiple parent records. In case of hierarchical model, we stick on there is only one parent and one parent can have multiple child. But in the case of network model, we are trying to establish many-to-many relationship between these linked records. In network model, entities are organized in a graph in which some entities can be accessed through several paths. A record may be a member or child in multiple sets, allowing this model to convey complex relationships. This is an example of network model where a student can be accessed from a department. There's a relationship between student and department. Again, there's a relationship between student and course. And there's a relationship between professor and student. So a particular node or particular entity student can be accessed in multiple ways, either from department or from course or from professor. And even the entity professor is related in many ways. They are related to department, they are related to student, and they are related to course. So thus many-to-many relationships are easily established using this network model. So that's an end for data models. Thank you. Stay home, be safe, have a good study time.